Hello all you Mustangs, welcome to beautiful California Polytechnic State University here in San Luis Obispo, but you can call it Cal Poly for short. It's not like there's any other universities that share that name. Since you've arrived here at Cal Poly, you've likely noticed that the quarter system is fast-paced and rigorous, leaving hardly any time for staying up late, swapping dank memes with your friends. You've also likely been placed or will be placed in a lab-based class where you will be expected to utilize Microsoft Excel. If you know Excel already, we're not sure why you clicked this video. If you don't know Excel, you probably could get by giving your data to your child prodigy lab partner, but we want you to be self-sufficient, so without further ado, here's how to use Excel well enough to get through your classes. In this video, we will be covering the features of Excel that are vital to producing your lab reports for general physics, general chemistry, general biology, and general competence. These topics include, and are limited to, inputting data, creating formulae, creating scatter plots from data, lines of best fit, and adjusting sig figs. Timestamps for these sections are in the description below, so you can skip around to the sections you need in order to avoid hearing my voice any longer than is absolutely necessary. Additionally, in the settings, you can adjust the speed of the video in case you feel I speak too quickly or not quickly enough. Warning! Excessive use of Excel may be linked to declined social acceptance, acute myopia, use of pocket protectors, and death. Just kidding. Nothing we will teach you today will cause physical injury. In fact, you'd probably have to try in order to hurt yourself doing this stuff. But please don't. You only need two things for this instructional video. The first is a computer. An Apple will work for this task, but we recommend you use a PC for this demonstration. And for life. Because they're better. At any rate, the differences should be minimal between the two operating systems. The minimum operating requirements needed to run Excel can be found by doing a Google search of System Requirements for Excel, or, if you're a lazy butt, by clicking on the link in the description. At any rate, any computer built in the last decade should work, so you're probably good. If you don't own a device like this, you may be able to snag an open computer at the library if you go between 7 a.m. and 7:01 a.m. on the weekdays, or 10 a.m. and 10:01 a.m. on the weekends. The second thing you'll need for this video is your own copy of Microsoft Excel, 2013 or later. If you don't have your own copy, you can get it for, free by request from the university. If you need to download that, just click on the Technical Service Request on your Cal Poly portal. Then, click on New Software Request and follow the instructions. The very first skill we're going to teach you is how to input data. First, select the cell you want to place data in by hovering your mouse over that cell and left-clicking. The selected cell is active when it has a border around it. If you're a klutz and you missed the cell you wanted, you can navigate to the correct cell by using the arrow keys, or by reselecting the proper cell with a left click. Once you selected the cell you desire the mostest, you can either type directly into the cell or left-click again in the formula bar and type your data in there. When you've finished, press Enter in order to move to the next row, or press Tab if you would like to move to the next column. If you realize the data you recorded doesn't give you the expected value, don't worry. Double-click on the cell to re-enter whatever value will better fit your curve. Now that we've learned the basics of data input, let's teach you how to create formulae. You can also call them formulas, but formulae sounds much more awesome, so we highly recommend it. In order to start a formula, select a cell and press the = key on your keyboard. Then, insert any numbers of operators you would like. For example, we type in equals 2 plus 2 and press Enter. As you can see, the forces of Excel magic have converted the value into the solution to that equation. But if we select the cell again and look in the formula bar, we can see the cell is transmogrified to represent the new solution. In addition to addition, the formula bar could perform subtraction using a dash, multiplication using an asterisk, exponential and power functions using the caret, and division using a backslash. Now, I have to be honest here, I don't know how much Excel follows orders of operations, so if you are mixing your operators, just use as many parentheses you need in order to feel safe. I know what you're thinking right now. You're saying to yourself, wow, could this get any better? The answer to that is yes, because we're going to teach you how to make an equation reference another column. For example, let's take this data here for % student health versus grams of food consumed at Metro. Looking at the swoopy nature of the graph, we can see that this is likely an inverse function, and we would like to linearize it. Instead of manually altering every data point, simply begin a new formula. After typing equals open parentheses 1 divided by, Click on the cell of the first data point of the data we want to inverse. After that, close the parentheses and press Enter. Now the appropriate number appears in the cell. To perform the same calculation for all of the corresponding data points in the column, left-click on the cell, and then hover your mouse over the lower right-hand corner of the bottom cell until the pointer becomes a black, solid plus with no arrows. Once your pointer becomes a plus, double-click, and the new column will automatically be level with the original column. And voila! You have yourself some fresh-baked data. Now that you have your data, it's time to create a scatter plot. We're going to start by clicking on a cell that's a couple of rows and a couple of columns away from your data, so the program doesn't automatically grab any data points to throw on your chart. After we've selected this lonely cell, navigate to the Insert tab. In the middle of this tab, you'll find the Charts section and click on the Insert, Scatter, or Bubble Chart icon. After clicking on the icon, we're prompted to select the specific type of scatter chart. For most classes, you'll use either a scatter with straight lines or a scatter with straight lines and markers. So we'll select one of those right now. At this point, you should have a completely blank chart on the screen. Surprisingly, we actually want it to be blank at this point. If your chart is not blank, delete it and try to make it blank again. Let's get some data. Ensuring that your chart is selected with this lovely gray border surrounding it, let's navigate to the Design tab found underneath the Chart Tools section. In that tab, click on the icon Select Data to open up a dialog box titled Select Data Source. Next, click on the Add button underneath the text Legend Entry Series to open up the Edit Series dialog box. Click on the Series X Values field, and then select the data column you desire for your X values using the Click-Shift-Click. Or by simply clicking and dragging your pointer from the first data point to the last data point. At this point, the Series Y Values field has probably been pre-populated, so click on that field, clear it out, and select our other data column for that. After you've selected the correct columns for your data, and you can double or triple check if you've got the right ones by clicking on the Series Blank Values box and looking at the highlighted data, click OK on this window, and the next window, in order to exit the chart editor. And just like that, you've made a chart. Remember, if you need to edit it at any time, simply select it, and then move over to the Chart Tools section to make any changes. Next, we're going to add a line of best fit, or a LOBF as no one calls it. First, click on the chart that you want to add the best fit line to. At this point, one of two things will happen. In case 1, a green plus may show up to the right of the chart signifying Add Chart Element. If this is the case, click that button, move down the list, hover over the triangle next to tread line, and then select the fit that works best for your data. In case 2, you don't have the Screen Plus option, simply open up the Design tab from under the Charts Tools section and click on the Add Chart Element button at the left of the header. From there, the steps are similar enough to the Green Plus option that we don't need to go over them. From here, click Add Chart Element, Trendline, more trendline options, and then select Display Equation on Chart to display the equation for the trendline. As a quick side note, you can use the same Add Chart Element button to add chart titles and axes titles. Something simple enough, we don't need to discuss it further. Now, sometimes you will want to display the number of significant figures that are displayed on this equation or another chart element. And when I say want to, I mean your professors will take off points if you don't. First, double-click on the chart element you would like to edit. For this demonstration, we'll use the trendline equation. At this point, a bar should show up on the right-hand side of the screen. Ensure that Label Options, that weird bar graph looking icon, is selected. Next, collapse any sections that are open so that you can navigate more easily and expand the section titled Number. From the drop-down menu underneath Category, select Number again. Input the number of decimal places you'll need for sig figs in the Decimal Places box. If you would like to adjust the decimal places on any other chart element, now's the time. Single-click on that element and repeat the same steps we just discussed. Once you have adjusted all of the elements desired, click on the X in the upper right-hand corner of the formatting bar close to the formatting bar and escape from Mordor. This concludes our presentation of the basic Excel skills you will need to succeed here at Cal Poly. Thank you for learning with us today. We know you had no other options, but are still amazed you stuck with us. By now, you should know how to input data, create formulae, create a scatter plot with proper axes, add a line of best fit, and edit significant figures on a chart elements. Again, if you need to review any sections, timestamps are in the description. Until next time, it's your friendly neighborhood nerd saying